Recall that in Chapter 3, we found x-intercepts of linear equations by letting y equal 0 and solving for x. We're going to use the same method to solve for the x-intercepts in quadratic equations. The intercepts this time will be where the parabola crosses the x-axis. So we've got the x-axis, we've got the y-axis, and we're going to have parabolas now for quadratic equations. So there should be 1, 2, or 0 x-intercepts depending on where this quadratic, this parabola is on the coordinate system. So we're going to write x-intercepts as ordered pairs. Let's find the x-intercepts for the graph of this equation here. So remember, we're going to let y equal 0 and solve for x in order to find those x-intercepts. So 0 equals 4x squared plus 11x plus 6. And if we want to solve for x, this is a quadratic equation, so we need to completely factor the other side. We first see if there's a common factor here, and there's not. So this is a trinomial. We want to look for factors of the first term and the last term that add up to the middle term. So x squared can only be x times x. 4 could be either 4 times 1 or 2 times 2. And 6 could be 6 times 1 or 3 times 2. I like to try the smaller numbers first, so let's see if those work here. A 6x and a 4x. Nope. Those don't work together. So let me just change the factors of 6. So we'll make that 6 times 1. A 12x and a 2x. Nope. That's not going to add up either. So that means we're not going to use 2 times 2. So let's try 4 times 1 with all of those combinations now. So a 4x and a 1x. Let's try 3 times 2. That's 12x and 2x. That's not going to work. So let's try 2 times 3 instead. So 8x and 3x. That might work. Let's check the signs. Same sign because the product is positive. They're both positive. So that does add up. All right. So we have our factors for this trinomial of 4x plus 3 and an x plus 2. Then we just need to set each of these factors that contain a variable equal to 0 by the zero product property. And we can solve those resulting equations. So first we need to opposite the number term and then divide any coefficients. So we get x equals 3/4. And opposite the number term, we get x equals -2. So these are the x-intercepts of the graph. We want to write those as ordered pairs, right? So that means x is -3/4 and y is 0, because that's what we set y equal to. And x equals -2 when y is 0. So these will be the x-intercepts for the graph of this equation. Some more examples where we want to find the x-intercepts, so as ordered pairs where y is 0. So we're going to set y equal to 0 in the equation here, and then completely factor the other side, which it already is. So don't waste your time trying to factor because it's already factored. Now let's just take each factor containing a variable and set that equal to 0 by the zero product property, and solve those resulting linear equations. So if we opposite the number term, we get a +4 for x and a -5. So if we're going to write those as x-intercepts, those will be ordered pairs where x is 4, y is 0. X is -5, y is 0. And another example here, we're just going to set y equal to 0 so that we can find the x-intercepts. The other side's already factored, so set each factor containing a variable equal to 0 by the zero product property. Opposite those number terms, and we will get answers for x. And then apply it to what the question is asking us for, which is x-intercepts of -1 and +1.